介嘅，我用喺度呢個手機。
你拎過嚟啊嘛？你拎過嚟啊嘛？
係。
Okay, now let's continue. Okay, are you ready? So now I go on to show you how we can construct this pattern, and I hope you have some time to explore, right, to know how it works. And particularly, I set the question there, right, to ask you to think about the three sliders or variables. What do they mean? Some of you have already asked about. Don't worry, you cannot figure it out immediately. But I think this kind of question should be useful, right, for the learners, the users, at least to give them a chance, right, to have an idea or try to figure out how the figures is changing and what way some features are being changed, even though sometimes you may not be able to accurately describe it, right? But don't worry about that. I think this is a process of learning as well. Okay? Now, so do you notice what n represents first of all? Number of edges or size, okay, of which polygon. And so you can see, for example, you can only see squares here. Right? You turn it to 4, and you can get more size in this way. And D, what D represents? Have you idea?
Numbers of shapes.
Yeah, number of shapes or images, okay? Because we are repeating it, okay? So it will tell you how many copies are made, okay? At first I use D because it stands for duplicate, right, from my view. But it doesn't matter. It's just a letter and a variable, right? Or parameter, sometimes we call it, right? To control the pattern. And how about T? What T represents? Now, of course, from the degree symbol, you should notice that this is an angle, okay? But the point is which angle, right? Do you notice? Now, maybe I make it simpler first. If I change D to 1, then you will see only 2 figures. Can you see that? Okay. Would it be clear to you now what this angle means? Okay. Now, don't forget that at the beginning, the center is here. The center of rotation is here. Okay. So maybe you have to compare 2 corresponding sides, right, to figure out how to see the angle, okay? And this angle applied to all the copies. That means if I make 2, then they are all differ by the same angle, okay? So this is how we develop or produce this pattern, okay? So what I'm going to show you is the step-by-step construction based on the understanding of the structure. Is it okay? Right. Now, meanwhile, I choose this example because it involves rotation, or in some sense, we start to talk about transformation. Okay, and this is an area that I'd like to introduce or propose more. It is in our syllabus, but it's not too much emphasis. Okay. However, in STEM-related projects, I think that this ideas or concept can be more fully developed or integrated with many other experiences, right, in other areas as well. Meanwhile, it involves some parameters. That's why I asked you to check what D, T, and N means, right? Because later on I will use commands to produce the figure immediately. I am not drawing the figures one by one. Unlike the first example I showed you, okay, it's not the drawing of the figures one by one, but it's just a quick productions of a number of big figures based on a command. So this part is more related to coding or computational thinking. Okay. Basically, when you involve transformation and if you're thinking of repeated transformation, then it will be also leading to a kind of thinking about repetition, okay, or sometimes similar to programming, how we break down actions and then go on to repeat the actions again and again. Okay. Now these are quite basics, I think, in computational thinking or coding. Okay. And so GeoGebra can provide this kind of experience or this kind of means. Okay. And this is exactly some things that we have tried in workshops with the students in secondary school, or even sometimes in primary school. Although in primary school, we cannot expect them to do a lot, right? But some other figures or patterns like this can also lead them to think in this way, right? Using the commands that we're going to show you. Okay, now, by the way, don't forget that one picture or one pattern, once you create it, can be easily modified. Once you allow those parameters to let you control the figure, then you find that there can be a lot of ways to change it. I also hope that this will help the student to see the richness of the pattern. It's not just one picture, right? It is a template actually, right? That can lead you to produce many other pictures as well. Or in case you can also, in fact, you can also talk about each of these pictures, right? How they are different from each other, what are some maybe certain characteristics about the figure. For example, this one, can you see how this ring is formed, right? In what way can you tell the rotation, for example, right? This can be also some mathematical question that the student can also work on. All right, so let's start with this drawing. Are you ready? Can you go back to the maybe I close this one. If you don't want to save it, okay, you can close it, all right? But later on, when you have your account, then you can save the file at the bottom. Right? That means online, you can always save this file. If not, then you just close it, right? Forget about this drawing and start again. Use the GeoGebra Classic. I looked at some of you may use other tools. Okay? It's up to you if you are more familiar with that. All right? But I use this one, by the way, only the GeoGebra Classic one. Okay, I enlarge the screen again. Okay, now the first, this time, the first step we have to do is to set up some slider. Okay, so you remember the few slider. One is about the number of size, one is about the number of copies, and then the angle of rotation. Okay, so we can do it here through this toolbar. Okay, when you are now in this side, sorry, I go back again. When you're now, I go back to the arrow tool again. I will show you. I mean on the right, okay, this graphic screen, all right. Then you can see this toolbar. If you're clicking, sorry, you're still adding this toolbar. Never mind. Okay, can you find this slider? Okay. The slider is a starting point to let you introduce some variable. Okay? So it looks like programming again. You have to define some variables or parameters to begin your construction. Although in GeoGebra, this is done partly graphically, so you can see the slider previously. All right, are you ready? So you just click anywhere on the screen to place the slider. Now you can name it. For example, the number of size I name it n. And it is a number from what? From 3, because the smallest one is 3. You can start have a polygon with less than 3 size, and it's up to any you like. Okay, maybe for this one I don't make it too big. Okay, just make it 3 to 8 increment by 1, so that they are all whole numbers. Okay. Of course, in other occasions you can also change the ingredient. Or maybe I can just click images. It's easier. I'm trying another way. I'm taking this image. Yeah, but it's just a big shortcut. It's not much different, I think. Okay, other options. Now this will let you decide how the sliders look like on the screen. Okay, or later on whether you want to animate. That means you want the values to change automatically on its own. Okay, I skip this part. You can explore it later. So when it's done, then it's okay. You have to turn back to the arrow to test whether the sliders work. Alright, you can click and see the values change. It's also shown on the left panel. Alright, the algebra panel. Okay. If let's say later on you don't want to show on both sides, then you can hide it. Then you can still be working here on the algebra panel. Is it okay? Okay. So the next one, you can continue to do it. Not add another slider. The next one will be, I call it D. It's up to you. You can name it in any way you like. It is still an integer. I will start from 0. I can create up to 100. And that means I can make up to 100 copies. Right? It's still manageable, right? But don't worry about the software. Right? I find that it can still manageable. Right? So it is now. Oh, why is it I? Am I doing something wrong? Sorry, I try to correct. I try to rename it. I don't know what happens. Oh, sorry. And okay, yes, I go back to D and use the arrow tool to try it. Okay, I think it works. Okay. All right. Can you follow? Right. The first slider here, the first slider will be the angle. Now this time will be a little bit different. Angle is different from number of integer. Okay. And, by default, it shows you the angle in degree. You can change it to radian to another setting later on. But for today, maybe we just work on degrees. Okay. So this shows you from 0 degree to 360 degree. You can change it if you don't want it. Increment by 1 degree. Or each time when you increase it, or use the arrow button in the keyboard, it will change by 1 degree each time. So it will be good for us. Now the name is alpha. Check carefully. This is a Greek alphabet. It's not difficult to press to input Greek alphabet because you have the keyboard here. I'll show you here on the lower left. I mean, in case you want to change it to alphabet, so I can open it now. Never mind. I can use the maybe keyboard later to rename it. So if you want to type it easily, then maybe you can turn it to other letter T. Okay? Even though Greek alphabet can also be easily used, in GeoGebra, say that. You understand? So I click OK. So I have an angle. So T here is an angle. Right? So you can see it so nicely here. Right? The degree of the angle. So far, any okay? Any problem? Now then, once we have this variable set, then we can go on to define the figure. Okay. So you will find that the process is quite like, from my point of view, it's quite like doing programming, because we have to define the variable and think about how it will affect the following constructions. And the rest of the thing, for time being, is still also geometric. That means you directly use toolbar to create the objects you like. You can create polygon, any arbitrary polygon, okay, by clicking some points on the screen, which I'll show you quickly to demonstrate what it looks like. So this will be a general polygon. That means the 4 points of the vertices can be freely movable, okay? But I'm not doing this one. What I want to do is a regular polygon, okay? So it is the second one I'm now using. A regular polygon is, and in some sense, you don't have to select all the points. What you need is just 2 points to begin. Right? Once you define one side, then they will generate the rest. Okay. So in this case, you can see the number 4 here. Right? Suggests that you will make a square. Okay. You can just try it, or if you make, if you input number 5, then you will have a pentagon. Okay. Now you can test it. Now this is what I mean. If you have the AP as a 3 point, then the rest will be generated accordingly. It is pentagon. Can you follow? Okay. Now, but still, this is not what I want here. Okay, I will do it now. Because what I like to try is to create a regular polygon with side n, which is a variable. Okay. So I click A, B again, and then now, in the number of sides, I simply input n. Can you see that? Okay. This time, the number of sides will be variable. Okay. So when you click OK, then you see it's still a pentagon at this moment because n is equal to 5. But in fact, it can be changed afterwards. Understand? And this will be more flexible. You will then later on be able to generate more interesting patterns. This is what I mean that we try to make good use of the variables, okay, in the construction. Can you do this? Is it okay? You can also see the objects here on the left. For example, point A, I start with 3 point A and B, and then I create a polygon. Now polygon has a name, poly1. Okay, poly1 is just a name for this polygon. You can also change it. If you don't like it, okay, then you can just create another name. By definition, it is a polygon. This is a command. Do you see what I mean? This capital letter P, okay, start with capital letter P, is a command polygon. And with the parameters A, B, and N, that means you need 2 points and number to define the number of size. So, in fact, you already see a command here. Okay? So, if you're not using the toolbar, you can use the input bar to input this command directly. Okay? Now, maybe let me show you what it means. For example, I can now use the keyboard. Do you see it on the lower left? I can use the keyboard. Or, yeah, the actual keyboard or the online keyboard is both will be fine. Okay? So I can now type, let's say, Polygon. Can you see that? You can use the actual keyboard, right, or the online one. Now, once I type Polygon, you can see the list, the options going out, right? So these are the commands related to Polygon. Right? You can check from the help menu later on. Right? You can guess what. Sometimes if you cannot remember, just make a guess what command you think would be. And so you see that there are different options. You can create a polygon by listing a number of points, or sorry, this is a list. These are individual points you make here. Right? Now this is the one we are using. Points, and number of vertices. Okay? Then it will be regular. But the other two are not regular, actually. Okay? This one will create a regular polygon. Okay? And so you can check from the help menu later on all these details, how to use it. Okay, so I can continue. Now I can just choose this one. Okay. Now you can see the help. You can refer to the help page. Okay. Sorry, I think I made a mistake. I just go back to the top typing again. Polygon. Okay, and then I use the bracket. Where's the bracket? And here is the bracket. Okay, and I need the point A and B, and then the number of sides. Okay, maybe now I press n+1 because I want to make a different one. By the way, you can use your own keyboard, but I want to show you what I'm typing here. Right? That's why I use the online keyboard. Understand? Can you follow? Okay. So now if I type it this way, then I will make another polygon A, B, and side n+1, not n. Okay. And to show you the value, this value is actually the area of the polygon. Okay. You can use it later, but for time being, it is not relevant to us. Okay. By the way, all the objects that we produce in GeoGebra, I can't say all, but most, right, will have a numerical value associated with it. It may be the area, length, angles, values, okay, or coordinates. So everything can be referred to by this numerical value, and you can work on those numerical values as well. And finally, if you want to give it a name, then you can press a new name now. Now this is the one. Okay, this part is just a name I give it. Okay, the previous one, the tool generate a name. Okay, for me, but this one I can use another name, easier one for me to work on later. Okay, so if it's done, then I can close the keyboard. then you can see a new polygon is formed. Do you notice that? Okay. Okay. So what I want to show here is that, in fact, you can always refer to the command and use the input bar to input all these things here. Okay. Now, particularly later on, if you want the student to experience more about the programming process, then that will be more useful. Right? So there are different options for you to try. Now, I delete this one. Okay. If you understand this, right, and then maybe I go back to the previous and just delete this. Is it okay? Okay, next thing, now we are ready to do the rotation, and then make a number of copies. Now let's look at how we work rotation first. And there are also different ways of doing it. You can refer to the toolbar again to find the transformation tools. Okay, so this is a list of transformations that you can do. Reflection, rotation. So rotation can be done using this toolbar. However, what I'm doing here is directly using the command. Okay, I just make it simpler in our case here. And now to really define a rotation, then you also have to first of all provide a center. Okay, so I now add another point. Can I add another point here? Okay. Now in my case, it's called the point I. In your case, you may have another point with another letter. Okay, because I've already generated some new points. That's why they will produce the next one according to the alphabetical order. Okay. Understand? This point I is a new point, right? A free point on the screen. I will use it as the center. Understand that? Now, in your screen, maybe you have another point and another name for the point. Okay, and you just use that name. Okay. So, how do you type rotate command? Now, these are the options. So you can see some other related commands as well. So we are going to rotate an object with an angle about the point. Okay. If you don't show the point, they use the origin. But this usually I don't use this one. I will specify a point to indicate the center. In fact, if you have a center, then it will be more interesting when you later change the center. Okay. Now that means you need just continue to type. These are just hints, all right? So you don't have to directly choose this one. You just type the brackets and then go on to remember what object you have to create, you have to produce. And the object here we're going to use will be the poly, right? Polygon, this polygon. And then the angle is T, and the point is I. I is the center, okay, to do the rotation. Can you follow? Okay. Now I'm now going to type it. Okay, can you see this? Now then, if you click on this again, you see there's a new polygon coming out. If I click on this cell again, then you can get back the command. But now when I go out, then you will see only the description. Okay, so you see how a new polygon with a new name, poly1 prime. That means a new name. It's another polygon created. So this is the part I want to let you know. What does it mean by making a new polygon based on rotation, right? And also with a center, with a specific center. Okay, can you follow? Yes. Where's this one? You read this code? Okay. Rotate poly1. Now poly1 is the name, right? Is the name. If you change this name, then it will be different. Okay? So you have to indicate which objects you are going to rotate, and the angle, and then the center. Now in my case, the center is the point I. I don't know what is the center. Okay? So you have to refer to the point you have as the center. Understand? Now, this is a basic demonstration to show you how I rotate the angle once. Sorry, I rotate the object once. Okay? So you get one image. But of course, you remember in my sample, I will produce a list of objects. Okay? That means I will continue to do it. Now in GeoGebra, we will use a command called sequence to continue, okay, to generate more in the same way. Okay? You understand? So this is the way we use GeoGebra commands. But there are other commands you can try later, because if you check the help menu, you can also find some other called if then or conditional commands or similar language. But I'm not using that now because it may not be so friendly, okay, in this environment. So I would prefer to use the sequence command, okay, to finish the work. But the idea is very similar. Okay. Okay, are you ready? Okay. Now I use the sequence command. Can you follow? Okay. Here is that just the word sequence. Then it will tell you it is a command for you to indicate a number of actions, okay, which is of course can be defined in a particular way, relying on a particular parameter or variables. All right. So you have to now produce an expression. I'll choose this one. Okay. I'll choose this one. Sorry, it should be the last one. Okay. So I will tell you. The expression here means another command. Actually, I'm going to repeat the rotation. All right? So I will put the rotation command here by the expression. Now, but the expressions will contain a variable because I'm actually going to repeat the rotation. Okay? So it's not just rotated by t degree, but t, the multiples of t. Okay? 1t, 2t, 3t, and so on. Okay? Up to d. D is the last one. Okay? If d is equal to 10, then I will give 10 different copies. Okay? So I'll let you know how I indicate the start value and end value and the increment. So it's very similar to other kind of programming language. Okay, now let me try here now. Now, so this part is similar to the previous part. Okay? So I'm now going to talk about rotation. Rotation of what? Rotations of Polygon. Maybe put it here now. Okay. Rotations of Polygon. Okay, it's similar to the previous command. And then I need to indicate an angle, right? T. And the major difference is that, maybe I try to finish up first, T and then, okay, now this part is basically the previous command I've already produced, right? Rotate polygon 1 with an angle T about the point I. Now I have to modify the angle. It's not just T, it's a multiple of T, which is described by another variable. So in this case, I just arbitrarily make a new variable for a time being. It's just it's just a variable for this command. It's not a variable actually in the main screen. Okay. Now I press P times K. Do you know how to press multiplication? The asterisk. I use the asterisk in the command. I mean, it's usually is it associated with number 8? Okay, it can multiply. Okay, that means use the asterisk in the keyboard to indicate multiplication. So it will be rotated by T times K. Okay. Now the rest is to indicate what K means, right, or how K change. So I continue to go back to the sequence command now, and then indicate K. K is the value that I'm going to change for this sequence command. Okay. So K will be starting with 0, and then the final one will be D. Now, in this case, since I'm using only integers, so I don't have to indicate the increment. All right. So by default, I just assume that it will be increased by 1 each time. Okay. So the k will be assigned from 0 to d. Okay. Can you follow? The dot. It is not actually a lot of time. Let me show you. Now, if you use the keyboard, you can use the multiplication sign. If you use the online keyboard, okay? If you are using your own keyboard, let me show you. What is this one? Can you see that? Okay. Usually, you just use the asterisk to indicate multiplication. But of course, if you use the online keyboard, then you really see the multiplication sign. It's both will be the same. So I have already finished. So now the thing is already generated.
Like the people. You make me hungry. Because no tuition and this verb so this I mean, maybe I should set it to integer in the first place. Oh, that's right. Integer. Yeah. My students, we can use laptops, but because I teach high school students and mainly calculus, so I think normally I'll use the Texas Instruments, the manufacturer that also produces calculator. They also have this graphing software. So that's the one. In the test, they are allowed to use
OK 其實我係暫時加個 variable 即係喺個 sequence， 即係喺個 sequence 嘅 command 裏邊咧，我要擺一個 variable 落去，顯示佢即係究竟重複幾多次，點樣重複法。咁個 K 或者用任何嘅 level 就出邊冇 K 個 variable。得㗎，不如你試下整個第個方先再嚟過，即係唔好離開你整個第個方。我再重新打過。我都唔知佢有冇北方。係嗱，而家我要用個 sequence 嘅 command 咧，咁我就要話俾佢聽我點樣重複咯。係啊，咁我就要譬如話，而家所以我就要加個 K 落去，即係個 N 咧就 T 乘1、T 乘2、T 乘3。咁所以我就要話俾佢聽呢個就 OK。OK 我呢度顯示嘅 K 咧就0，咁佢一個正常。咁所以咧佢會開始成0啦，跟住1啦、2啦、3啦。 sequence 嘅意思即係話咧，佢會令到個 K 咧一路咁變啦，咁就會從 R 嘅 rotation All right. Now let me explain further the sequence command. All right. Now in fact, maybe you can check the help menu later, right, for more information about the sequence command. Now I hope that for the workshop here, I just give you maybe the example, right, so we can continue to try to get a sense what's going on. Now maybe I'll explain in this way again. The expression here basically is the rotation command. You notice that? And the expression here is exactly the same of the rotation command. The major difference is the angle is now not just t, but what we want is we want the angle to be t and then 2t, 3t, 4t, right? So how can I ask the computer to do all these rotation one by one? Then I have to make temporarily a variable, call it k, so k times t. Where k will be 0, 1, 2, 3, 4. Right? Now it is indicated in the rest of the command, saying that k will run by, from 0 to d. D is the last number I already mentioned outside, okay, in the job graph windows. Okay, can you see that? Alright. So hope that you can get used to it. So now for this command, the variable k is just for use within this command sequence. So you can repeatedly use the k in another command, doesn't matter. It won't affect other things outside the command. Okay, I mean in the graph window, we don't have another additional variable k produced actually. Okay, now maybe we test it now. I go on to the move tool to see how it works. Okay. Now I can perhaps hide the first image that produced. Now what you see is just the result of rotating the figures a number of times by the sequence command. You can also change the angle in this way. You understand? Understand how it works? Okay. Now, let's go back to this result. Now, this result, I mean, after the sequence command, you have a result. It's called L1. Okay. It is a list. If we check it, okay, you can check it. It has a name, L1. It is a list. Okay? So it is not shown directly, but it actually represents a list of objects. For example, in this case, it is actually represents a number of polygons, right, already produced. And just like any other objects, you can change its color or change its style. For example, maybe you want to change this opacity, okay? Now you can see that I now already changed it. Okay. And so when you continue to change other part of the figure, then it will modify accordingly. Now I think that should be all I want to demonstrate in this part. Okay? Is that okay? Now let's check my original file. So this is the one with the polygon. Yeah. Now, so in this case, I create an object by rotation, and at the same time, I also repeat the rotations a number of times so that you can produce a more interesting figure, right? And what's going on in other examples that I'll show you, I continue to use this similar tools, okay? Maybe transformation, and then together with the sequence command, and then you can quickly produce a lot of interesting patterns. And while doing so, basically, we are also doing something in directions of programming and coding, okay? Because what you see here, the setup of the command is very similar to other programming environments that some of you may be familiar with. Right? And of course, this process also requires students to think in such a way how the objects can be arranged, or how the actions can be repeated and be described, right, appropriately using the expressions. Now, how about, okay, let's go back to the, in the first page, right, in the guide here. Now, in the workshop guide, I already produced the source of these materials. Because I mentioned earlier, they come from some of the workshops that we have really run and designed for students. And for the one about symmetry, transformation, tessellation, you can check this one. There are other materials provided by my colleagues, to introduce STEM-related examples. If I click on the second, to get some examples, you can see my examples here. Maybe this is not the one including the examples I want to show. I think I tried the first one. Now you can see more examples like this. Okay? I will show some other later. So they are basically generated by the same types of command. Okay? So including this kind of sequence and also transformation. And particularly these three, the one below, they are selected from students' work. Right? Once we tell them, okay, we can basically use this kind of command, then we invite them to try to design some new things. So you can click on this one later, right, to find out what some students have been doing in the workshop. Right? Try to make use of the command we introduced. Right? So this is a process that we hope that we can make use of only a small number of basic and simple commands, but go on to design a lot of things on their own. Okay? Now, so in my file here, the next one, maybe I explain a little bit how we use it in the course. Now I don't do the details now, but if you look at this one, this is called stitching. Okay, it's similar to some drawing that sometimes school students have tried with paper and pencil. Okay, line stitching, curve stitching. Okay, and they are also produced with some sequence command. Okay, can you see this one? Okay. Now you start with the first one here, and then rotate it 4 times, and the number of divisions or partitions can be varied. Okay. For example, you start with 10. Okay. Now you can see that the file actually, if you just look at the left side, is very simple. We just a few lines of command. Then we already produced this figure. And this one have also been tried out in some course with primary school students. Okay. Now, of course, it takes some time for them to understand the sequence. Right? It's not easy. Okay. but I want to let you know it has been done in some primary schools workshop as well. Okay? Of course, we don't directly tell them what the sequence means. Right? We ask them to do the segment. Can you see the segment command? In the middle here, right? The segment here means a command to connect two points, okay? And then draw a segment. So we ask them, first of all, to draw the segment one by one. Right? Actually, it's copy and paste. Right? Once they produce the first segment, they copy and then paste the command line again and then modify the parameters. That means the two endpoints. Then they will produce another one. Okay? So we really ask them to produce the line one by one before we go on to suggest a sequence command, so that actually they know what the sequence represents because they really have done already the individual lines. Okay? We only want to tell them later that the sequence command can be used to replace all the work in a very efficient way. So unlike what you have done, I haven't asked you to rotate the shapes one by one. That's why some of you may get confused. How come we can generate immediately? Okay? But I also let you know in the actual situations of workshop with the student, we modify the task, right? And we modify the process a little bit to meet this. Okay. Okay. Now, so you see that the first one will help you to generate a number of lines. Okay. And then the rest will be the rotation. Okay. So that is the structures of this file. And now, because of not much time left, can I now move on to the transformation tutorial to let you see a little bit more what we can do with this kind of combinations of commands? Is it okay? Now, what I want to, can you see which part I'm now looking at? All right, this rotation and dilation. Now, at the end of this set of tutorial, okay, you will produce a spiral, something like this actually, okay. But once again, we can do it in a very simple one or two lines of command, okay. But of course, at the beginning, you can experience a little bit more of generating the individual objects in order to get familiar with the structures of the pattern first, okay. Now, I'll tell you why I asked you to do spiral. Okay? Not just rotation, but rotation together with dilation. You know what dilation means? Enlargement. Right? Scaling up, scaling down. Okay? And so this will produce, if you combine these two transformations together, you produce a spiral. Okay? And the spiral, the basic spiral structure is it's very interesting and can be modified in many different ways, right, to produce a lot of interesting patterns and figures. Okay. Now the basic design is like this. Yes, you start with also two sliders. Okay. In this case, one is controlling the angles, and the other one is a ratio, right, controlling the size of the dilation. Now, for example, if you turn to 0. The angle turns to 0. There's no rotation, okay, but only dilation. Can you see that? Okay. And for dilation, mathematically, we should also define the center. So I use the same center for rotation and dilation. Okay. For example, now this object, this polygon, the original triangle, is being dilated by ratio. It can be greater than 1 or smaller than 1. You understand? Okay? And I do both things at the same time. Okay? Rotation and the dilation. Now, if you want to try dilation alone, you can do it this way. Maybe now open. Now let me tell you, first of all, how you can do with this tutorial. In one page, I already provide different examples. Okay? So you can scroll down to work on individual examples, and if you follow my suggestion, try the command that I suggest, and then instead of starting from scratch, okay, because I want to make it simpler. Okay. Can you find this file? Can you find this file? It is the first picture in this page. Okay. Maybe I just enlarge it first. Enlarge this page. Okay. Now let me show you where you find dilation. Dilation is here. or they call enlarged. Sorry, maybe well, it depends on the version that you're using. Sometimes I call dilate, sometimes I call enlarge. Then, so you can check, if you choose enlarge, you can see what it do, or you can put in the input bar here directly, okay, enlarge. It's a bit strange there because I find that they use the word enlarge, but here I use the word, I use the command dilation. Okay. So I don't know. Sometimes they change quite a lot the wording. Okay, so can you see this? Can you see what I've typed? Okay, so I enter it. Now then, this is one example. This is a polygon. And this is the one I just recently entered. Okay, it is a dilation of this polygon by ratio 1.5. Okay, so this is what I've typed. Okay, so I do it again. The command is like this. Okay, so why there's no suggestions here? It's interesting. Okay, then never mind. Right. All right. Let's just maybe simply conclude like this. So you can use the dilate command this way, indicate the objects you want to dilate. Okay, make it bigger or smaller. But actually, whether it's bigger or smaller depends on the ratio. All right. When I put the ratio 1.5, then it becomes bigger. It can be 0.x, for example, then it's smaller. And the center have to be chosen as well, right? We have to indicate that A, for example, is the center of the dilation. You understand that? All right. Now later on, I will use the sequence command again, all right, to ask the program, all right, to dilate the objects repeatedly. All right. In this way, then the ratio will be changed. Okay, it's not just 1.5. If you dilate it 2 times, then what should be the ratio? That's 1.5 squared. Okay. Similarly, if you wanted to dilate 3 times, you want the 3 copies, right? And then the third one will be having the ratio 1.5 to the power 3 cube. That means, okay. Similarly, right? So you have to change the ratio in this way. So the key idea is the ratio, right? How do you adjust the ratio? Okay. Now, but more than that, in the program, if you look at this part, you can follow it. Okay. So follow my suggestions here. I already indicate what you can try. Now, it may look more complicated, right? Can you see what it means? In the inside expressions tells you can rotate the polygon 1 by an angle t. T is already given, okay? About point A. And the whole thing is another object which you can dilate. Okay? That's why you do 2 things at the same time. Okay? Of course, you can break it down. In case you have more time, then I'll show you how I do the rotation first. I have a new object and then I dilate it. Okay? But in fact, you can combine it into one command. Okay? So what you see is you do the rotation in order to generate new objects, and these new objects can be the objects to be dilated, okay? Based on the same center and a given ratio. And that is the way that you will produce this figure. So that means, for example, it can be rotated by 45 degrees with a ratio 0.7. Okay, then it will be like this. Now later on, if you repeat this process, I mean both rotation and dilations repeatedly, then you will have a spiral. Okay. We can give you some time to try it because I already put down the instructions. Okay. The next screen will invite you to try this process one by one. That's why I will show you how you can produce a number of figures if you repeat this command. Just copy and paste. All right. And then you can see a series of figures coming out. And when you move on, then I will ask you to try to express the last one. That's why you can see that the command inside it, okay? It will be represented as n times t, and then r to the power n. Depends on how many copies you want to finally produce, okay? So in this case, then you will see the last one. Depends on what n is, okay? So let me see how I vary or change the variables, which is the ratio and angle. And once you understand this command, then you can go on to the next screen to see the sequence command. Right? Because once again, I use the sequence command to do all these things in one step. Okay? And so you can try to see how the figures can be generated here, including the spiral. The last one will be the spiral. Now maybe I let you try a little bit here, and I will follow these few screens, okay, to see whether you can make sense of the commands. Right? And meanwhile, maybe I will come back to the discussion again after 5 minutes. All right. So not much time left behind for the workshop today, so it will be not too long for you to take a rest. In case you want to make a short break, okay, then you will take 5 minutes, okay? Or try out with the examples I showed you. Okay?
So that is why lots of students actually suffer during calculus class, during online class, because it's very difficult formulas and calculations are already very complicated. And you need to understand the rules, how to do integration, how to do, and sometimes they always ask me, how are we going to do this? So what I told them is that probably you won't use it in your real life, but if you think you want to be an engineer or something like this, calculus in English is very important.
咁其實佢係可以有時間做個試驗嘅，你又唔一定做，可以玩。呢個到最後我先話俾你聽，咁你一次過即係要先嗰個咧，就變成咗一個即係方程嘅，即係好多時都會用一啲寫晒好多嘅 action。如果唔係你都唔會做到呢啲集啦。
But fortunately, the calculus class is not open to all students, only the students who are interested.
我而家講緊呢個視頻嘅學生咧，純粹需要咁佢就即係唔係等同呢個學緊啊呢啲或者做緊啲書。不過咁啱呢個例子咧，就正正就用翻校園分析同埋書所述。所以點解我叫佢將個 T 就不定咁樣乘咧？其實個 T 你如果要用呢個嘅時候，
in secondary
講道理，如果 ratio 兩樣嘢有 ratio
即係如果要將個放大縮細咧，你要將個 ratio 咧，要 you can rely on some like functions. For example, I want to find the volume of an irregular cylinder. Let's tell me what's the volume of an onion. Things like that. You can use them as a model to tell the students. You can use this model or workshop models to find the volume of an irregular cylinder. In college math, I majored in applied mathematics. They focus a lot on theory, how to prove. Okay, let's say we have already have a formula, we already have we need to first prove that this theory is correct. It's not like prove that these two triangles are congruent to each other. Not like that. It's all abstract ideas. It's pretty difficult.
But you finished.
Yeah, I survived my college. But actually I have a classmate who's still doing research in the applied mathematics. If this is just theory, you prove something theory, and you prove that it can be used to solve some problems. But according to my classmate, he said that lots of his research studies now has already used adapt with real industry need.
But I thought it was about like modeling some real life situation and do some mathematics.
Yeah, you model something situation, you use math to solve the problem, but problems, if you rely on theory it's too advanced. It progresses much faster than the real industry. So for example, my classmate is doing research on control theory. Basically, use math to design a model to solve some problems in factories. But the facilities in the manufacturers didn't change much for that in the preceding decade. Yeah, in theory, that the devices he designed would be very efficient. But installing the device would take a lot of money. So lots of factories, manufacturing industries choose not to upgrade this. Because it's not cost effective.
He also considered real problem on those channels. I don't know.
Actually, his boss had already seen the problem.
Really?
But they're still doing research study. They are still doing research on this field. And according to his professor, he said that, I think in science or especially in math, their research study is always ahead of real industry. Yeah, they have the need, and they still want to solve the problem. But the thing is that in the lab, if you do pure science or pure theoretical model design, it can be difficult to implement because we do not have opportunity to implement, to do trials, to do tests. So that's the problem.
It's not only us three, it's everybody also.
Okay, can we continue now?
But fortunately, they still get lots of funding.
Alright, can we continue? Okay. Now, go back to the example. So you can see that this is the basic means to produce a spiral using this command. Alright, so I repeat again. We do basically rotation and dilation each time. This can already be combined to make one action. And the sequence command will repeat this action a number of times. So the result will be a spiral. Okay? And you can also continue to play with it because, in fact, the way you define the ratio or how the original figure is produced also make quite a big difference. Let me try to show you here. Do you know why I can combine all this triangle together? Do you see what I'm doing? You see that? If you adjust your first triangle appropriately, then they will all stick together. Okay? Do you notice that? Okay? You can further figure out how this ratio will affect the overall image. Okay? Okay. So you play with this, even though it seems that it's just a general pattern. However, if you check carefully, the ratio and the angle can be related to this triangle's own angles and ratios of sides, in order to make more specific arrangements. Now, finally, I would like to also let you know why in our course or in our workshop we like to deal with spiral. Okay, and first of all, you can already see that I can produce quite a lot of different kind of combinations and patterns. It may be interesting as a result or as a kind of product to show the student. But at the same time, mathematically, it's also very important because in the mathematics curriculum, you should also notice that we also learn about arithmetic sequence and geometric sequence. In different stages. Maybe in the earlier form, we also come across this, but we may not use this name. Of course, in higher form, then we explicitly deal with this kind of mathematical objects. And in this spiral constructions, we are dealing with two types of sequences at the same time. Or get the student familiar with the ideas of this kind of geometric or arithmetic sequence in this more complex environment. So that is quite different from what they experience in the textbook. Particularly, the dilation involving ratios and the repeated applications of the ratio is also a challenging concept for many students. So we hope that with this more concrete ideas or production, they will have a means to understand or make sense of this mathematical ideas in the long run. And go back to the commands or to the programming here. It is also quite naturally an extension. If you want to repeat the process, of course, they will use the sequence command. Now, of course, I understand that in other programming language, you will use other syntax, obviously. But the basic ideas will be very similar from my point of view. So we are also making use of this kind of means or tools to repeat action in order to accomplish a more complicated result or figures. And now regarding sequence, I hope that you can find out more from later examples, or even go back to the mathematics as well. From my point of view, the spiral construction is a very important or very useful means to learn a lot of mathematical ideas in a useful way. So this is another example. Let me check. I think this is the final product. Yes, this one. Now you can see that this one has a little bit modification. Now I don't go through the detail with you now because we don't have too much time. But let me explain to you some characteristics of this figure. Do you know what's the major difference between this one and the previous one? I also do a spiral, right? But the ratio of the spiral is given by this ratio. This ratios of size of the first triangle. Okay? Oh, it's not a slider. It is a result of this calculation. BCD can be changed. BCD can be changed dynamically. Then the ratios BC to BD will be changed. Okay? I make use of these ratios to do the dilation. At the same time, I use this angle. This angle is also divided by the triangle. Okay? So this triangle angle gives this angle, and I make use of this angle and ratio to do the spiral construction. So that's why all the triangles automatically stick together. You notice that? Okay? So you can think about this mathematical concept, right? Later on, if it's not directly obvious to you, right? And so you can see how we can modify the figure based on the same principle, and then do a little bit more interesting constructions. This is just another add-on, right, to the previous figure. And or in another case, if it's not a triangle, it can be other figures. For example, this is a square. Can you see this construction? Do you notice that this is also a spiral? It is also dilation and rotation. Okay? I start with a square, right? And then I choose any point on one side of the square. Okay? And once you fix this side, then you already know what will be the ratio. But of course, we need some calculation. Okay? But for today's workshop, I'm sorry, I will skip this step. Okay? But as you know, once you have designed one point on the side, then you should already be able to figure out what's the ratios of two successive squares, right? And at the same time, you can also know the angle. Okay? The angle is actually the same, defined by AF and the center of the square. Okay? And in this way, then you can continue to rotate and dilate the square to generate this kind of pattern. So that is the reason why the basic setup can be continued to modify, right, to produce many other different kind of configurations. Now the next one, okay, I think I have to move on. Just to continue because just only not too long left behind. The next one, I just briefly describe it here. It is still about transformation, but it is all about tessellation. So this time we focus on only translation. Okay, translation. Once again, translation is another transformation we learn in our curriculum. But the most important thing is not just learning the mathematical ideas. Okay, I think even though they do not formally learn translation in school, they can still make use of the arrows, okay, to define the movement. Okay, even for primary school students, you can let them know we are just using certain arrows on screen to define the movement, and they can make use of it to produce many different figures. Okay, so for translation. Basically, we need vectors. Okay, so you can generate vectors in this way. Clicking any 2 points on the screen. I skip this step here. I'm not really show you the detail later, right? But let you know the basic idea. Once you have the vectors produced, then you can make use of the vector to do the translation. They have of course translation command. Okay, you can scroll down to see the translation command. Yes, this one. Polygon, okay, it's based on the translation. And so it's not shown here. And you can do both translation at the same time, so that you can see how the figure is being moved around, right, on the screen and the plane. Now, making use of this setup, then you can make a series of translation in one direction. Okay? And similarly, you can make another translation of a list of objects once you make the first one. Okay? And based on this, then you can think about how to produce a set of objects and make them tessellate. Okay? So the final objective is to try to see tessellation. For example, in this environment, if we are using the diagonal of the starting polygon, then you will quite easily have a tessellation based on the polygon, right? Based on the quadrilateral. So this is the final one. Right? The translation is based on the vectors, right, divided by the diagonals. You see that? Now this is so this tutorial will show you step by step. Right? If you go through it, you can see the command I produce in each case, or even some video to let you know the step, because I already prepared beforehand. In case you don't have time, then you can try to study later on if you want to know more about this. Now these are more advanced combination. Okay, so I'm still using the sequence command, okay, but putting them together. So you can work on any kind of objects, not just polygon, but maybe in this case just a list of segments joined together. And so these are more examples that you can see. Combining translation and rotation, okay? And later on, if you go on to check my sample, and you can find that we can combine all these together to make more interesting pattern. Just have a quick glance here, right? These are fill segments joining together, and I can repeat this segment in a systematic way. The first one is to do the rotation. Rotate this configuration, rotate it to make a copy, and then translate it. Okay. The result, in fact, will be a series of congruent pentagons combining together. Okay. So this is the final result that you can see. Okay. So I hope that you will find it interesting, or maybe you can go on to explore how we can combine all these techniques together, right, to produce other kind of results. Now these are all about tessellation, because both the transformation and tessellation materials are tried out in the workshop I mentioned earlier. Okay? And so I particularly extract them so that you can go through them maybe one by one. I see a setup I show you, and you can try it out to see how the commands can be used. And now I briefly explain the other materials that I prepare. The other set of materials is about animation. I pick up this one to show an example. So this is an example of animation. Okay, can you recognize some familiar mathematical objects in this screen? Sine. The sine curve, right? You see the sine curve. Anything else? I mean all these mathematical objects actually. Okay? You can see the sine curve. Can you see the parabola? Yeah. This is the parabola, and this is two circles. That's all, right? And how can I make this file? Now I've already prepared the details, so you don't have to look at my demonstration now. You can click on the PDF file. Okay. This is already recorded in the PDF file. Okay. And well, you can try to study it later. And actually, if you study carefully, all these are in our mathematics curriculum. Okay, so they are not out of syllabus. Okay, you see that? So they are actually the mathematical equations that include some parameter, so that you can change it. Okay, the constant A is varying. A and B are the constants that can be varied. Okay, so that you can see how the whole graph can be moving in a certain way. Right? Now, of course, combined together, it can be another kind of project for the student to think about in what way this basic curve can be combined together to make different kind of animation. Okay? I also give you more, you can follow the step one by one. I'll show you, because some of the intermediate steps require you to mark the intersection. So these are intersections of equations, actually, of the graphs of equations. And also you have to produce an integral, right? Because they will not color the regions for you directly, okay? Unless you produce an integral of the two between the two curves. Okay? So these are the basic ideas it shows in the graph. Okay, so this set of examples are more about animation, right? And it can be another type of projects I mentioned to invite the student to think about how they can make use of the simple mathematical objects together with some concepts of parameters and variables, right, to produce new things that they like. Now, I think this is the last set I want to share with you. Okay, it is more about modeling. Okay, and it involves exactly the kind of questions like sometimes we call problem-solving questions, or maybe design questions. Okay, in this case, I'm choosing some questions about maximum and minimum. Right. Now, of course, some of you may come across this kind of question in calculus. Right, but my focus is to use this digital tools. Right, to help the student to understand the problem and even go on to explore it without necessarily using symbolic method like the calculus. Right? So these are also very useful and in some way. And nowadays we can call or maybe consider the kind of modeling problem, and it can be further developed in many other ways. Okay? Of course, I choose a familiar object, a cone, to talk about it. However, you can modify the question or consider many other situations like this, where you may want to find some kind of optimum result and may involve some kind of experiment, because I'm not totally relying on symbolic calculations. Right? I'm thinking about, in terms of STEM context, we are thinking how we can make models, how we can invite the student to try out prototypes, okay, to modify it, correct it. Now these are more related to scientific inquiry. So under this STEM umbrella, we can modify a lot of math teaching learning materials in a new way. Okay, now let me show you what are some of the material I include here. Okay, the first one, it is about a paper cone. Can you see this? Now, on the left, it is a piece of circular paper, okay? And you can decide how big a sector you make. Now, in fact, in the past, when we do not have the demonstration here, we simply use a paper cone, the circular paper, right? Ask the student to guess what angle they can decide to make a cone, which will give the biggest volume, right? The largest volume. And on the right, you can see the 3D model, okay? I showed you beforehand that now GeoGebra can also produce 3D figures, even though today I do not have time to show you the details, right? And this is part of the features of the GeoGebra, right? In producing the 3D objects. And so you can see how the cone can be formed, right? But my question here is that, in what way the angle can tell you the size of the radius of the cone? Provided that you know L already, because in the process here I do not change L, right? I change the angle, but when I change the angle, then the radius will also be changed, okay? Now this is a typical textbook problem actually, because we need this to formulate the formula for finding the surface area, okay? However, this setup can help the student to visualize or to try to think about it in a more concrete way what we are talking about. Now, by the way, I'm not asking the student to make this model, okay? This is just a model to show you that we can do it in the GeoGebra. Without GeoGebra, you can talk about it with paper, circular paper, right? To talk about this problem. But the next one, the later one, will further talk about the maximum volume idea. For example, this one, I worked on the previous one, and then the question will be extended. What angle of the circular paper will you choose in order to make a cone of the biggest volume? Okay. Now the point is, how can they see the change of the volume when the angles change? Alright. Now I will concentrate on the generation of this graph. Okay. Now, why, as I mentioned, I do not expect the student to produce this one. I don't mean that they have to produce this figure, which will be more complicated. Although I already include instructions, PDF there. You can follow the link, and then in case you are interested in producing this figure yourself, you can follow some of the suggestions that we provide. But for the students' work, our focus is on the graphical, okay, ideas. You understand? And if I turn it into a student project, then my focus will be whether they can see the variables. Right? That means when the angle change, how the volume will change, even though you don't have an equation for this curve. Do you know why? Because we just generate this equation from numerical values. Right? We just change the angle, right? And then obtain the values of the volume through some calculation, but not one equation. Right? Some of you may wonder, can you describe one equation? Of course, with advanced mathematics, I mean a little bit advanced mathematics, we can describe this curve. Right? But the point in the lower form is not about describing this curve or generating this curve directly. It's about gathering some numerical values from the experiment, and then talk about the graph, and then think about the maximum volume. Okay, so in this graph, you can see the result will be shown in this way. Okay. Now then, I'll show you quickly how it can be done. We have two ways of doing it in GeoGebra. This is one way. Okay. Now, this time I skipped the picture because the picture is not directly involved. What we need is to decide the first variable is the theta, the angle of the center. Okay? And another constant we have to fix it first is the size of the circular paper. I call it L. Okay? L is the size and the radius of the circular paper. Okay? And this is also the slant height of the cone, actually. Okay? And the rest, H, R, that means the radius of the cone, height of the cone and volume of the cone can be found out by simple calculations step by step. If you have the tools, right, then you can do it with a suitable formula. Once you have this value, then you can plot the point on this graph. Right? Then they already have the basic means to study this kind of optimization problem, even in lower form. Now I'm talking about junior secondary, not advanced level actually. Okay? Because in junior secondary, they can already, with suitable means, go on to start thinking about this kind of modeling problem. Okay? Now, may I describe briefly how it can be worked? Right? Now, the first step is similar. You need a slider, right, to define the variable theta, and then you need the L just to make sure that you have a means to fix the size of the circular paper. Right? This can be changed afterwards if you want to. What will be the next thing you can find out? R, H, or B. In my previous figure, actually, I encourage the student to go on to find out R. Okay. Now, in the GeoGebra interface, it's very simple. Just type R equal L times theta. Theta is there over 360 degrees. That is R. Okay. R is the radius. Of course, you have to go back to the previous demonstration to know why this relation should be correct. Okay. By the way, this should be understood because it is a first step of forming the formula, right, for the surface area. Okay. And once you have the R, okay, now we go back to the value. This is the value, okay? And this value of R is changing because if we change theta, then the R will be changing, okay? The next thing will be H. H, ordinary, the formula that we know, just input it, okay, with the keyboard. Then you L square minus R square square root. And this is another value. Then you see how they change. Okay, so all these are adjusted immediately. And finally, the volume. Of course, the volume is just a formula. Now, you notice that basically all these formulas are the standard ones. They should know. I don't combine them together. If you combine them together to form one equation, that would be very complicated. Okay? But what I want to emphasize is that all these can be calculated step by step. Then you finally have the volume. Right? And the next thing you need is to plot the point. This is the point A. Right? Point A. Now, forget about the change of the angle here because I think we can modify later. But what we need is the angle and then the volume, right, as a point on the screen, and then make it change. That's all. Okay. So when you put the point there, then you will see how the point change with the theta. Okay? And the blue curve is a locus. Right? We can mark the change of the point as a locus. Right? Instead of a graph. It's not a graph with point, it is a locus of a point that you can see on the screen. Now finally, this problem can lead you to think about what should be the angle in order to make the biggest one, or maybe at least more or less the biggest, right? The biggest one. And once again, this problem has been discussed with Form 2, Form 3 student. Not average student, not very advanced student, not very, what I mean is particularly able students, but they can, with suitable means, they can also talk about this kind of mathematical question and ideas. Okay, so this is one possible way. Another possible way, I'll just show you quickly. In fact, it is even more traditional. I guess some of you, I don't know whether you've come across this or not, is simply use of the spreadsheets. Okay? GeoGebra comes with the spreadsheets. You can open a spreadsheet in GeoGebra. But what I want to show you is that we can even go to Excel, right, to talk about this calculation. If you can calculate all this value just one by one, then they can see the change of the values and then talk about this variation as well. Okay, then maybe, okay, it's time now. We will stop here and hope that you can find some possible ideas to develop your STEM project, and or even for your own use, or in case you're working in maybe math teaching activities. Okay, thank you very much.